Okay, this is still 7-6 about exponential functions. This is the graphing portion of it. So this is the part B. We can remember our exponential function is of the form y equals a times b to the power of x. The big red flag that's exponential is your unknown. Your x is your exponent. So when we go to graph this, y equals 4 times 1/2 to the power of x. We can see it's to the power of x, so we know it's exponential. I would start with the number 0 to plug in. So when I substitute in 0, I'd have 4 times 1/2 to the power of 0. Anything to the power of 0 is 1. 4 times 1 is 4. So we have the point 0, 4. I can plug in 1 next. So if I do 4 times 1/2 to the first, well, that'd be 4 times 1/2, which is 2. So we've got the point 1, 2. Then I'm going to go one more. I'm going to plug in 2. So when I substitute in 2, I'm looking at 4 times 1/2 squared. Remember, when you square a fraction, you square the top and the bottom. So that'd be 4 times 1 squared is 1 over 2 squared is 4. A fourth of 4 is 1. So we have the point 2, 1. So then, like we talked about, you can either use the table or the equation to figure out the pattern there. So we can see 4 times what is 2 times what is 1? Well, that would be multiplying by 1/2. You can also see that in the equation because 1/2 is the base. So if I go out to the next one, 1/2 of 1 would be 1/2 to get the point 3 1/2. If I go out to 4, half of 1/2 is a 4th. Then I would be at an 8th, and then at a 16th, and so on. So what is happening on this side is it is approaching 0, but it's never, ever going to get there. One of the sides of an exponential always approaches 0, but it's never going to get there when it's in the form y equals a times b to the power of x. So then to find points on the other side of 0, we can either plug in values or take the pattern backwards. The opposite of multiplying by 1/2 would be dividing by 1/2. So 4 divided by 1/2 is 8. So when we were at -1, we would be at 8. I could keep playing this game. 8 divided by 1/2 would be 16. So at -2, we were at 16. So what happens on the other side of your exponential? It either goes up super fast like this one, or it's going to go down super fast. So one side of your exponential goes up or down super fast while the other side is approaching 0. And we can see it gets faster and faster as you go, right? So we can see here, it went up by 1, then it went up by 2, then it went up by 4, then 8, then 16, then 32. It just keeps going up faster and faster and faster and faster. All right, so our next one, we have y equals 1/2 times 4 to the power of x. So again, I'm going to start by plugging in 0. So let's see, 1/2 times 4 to the 0 would be 1/2 times 1, and 1/2 of 1 is 1/2. So we have the point 0, 1/2, adds up there. If I plug in 1, I'm looking at 1/2 times 4 to the first. Well, 4 to the first is 4, half of 4 is 2. So when I plug in 1, I get out 2. If I go on to plug in 2, I'm looking at 1/2 times 4 squared. Well, 4 squared is 16, so half of 16 is 8. So I've got the point 2, 8. So after 8 then, multiplied by 2, I'd be at 16, then 32. So I can see going to the right, I'm going up super fast, like crazy, forever. Because the pattern here is that I'm actually multiplying by 4. Half of 4 is 2. 2 times 4 is 8. So I misquoted on these numbers here, right? 8 times 4, I'd be at 32 next. So then if I want to go the other way, the opposite of multiplying by 4 would be to divide by 4, right? So that would have me at 1/8 and then at 1/32. Because what's happening again on this side over here is it is approaching 0, but it's never going to get there. So one of the sides goes up or down like crazy. So both examples 1 and 2, they went up like crazy on different sides. And then the other side is approaching 0, but it's never going to get there. Same thing on 3 and 4. On number 3, I'm going to go ahead, start off by plugging in 0. right? So let's see, negative 1/4 times 2 to the power of 0 would be negative 1/4 times 1, which is negative 1/4. So I've got the point 0, negative 1/4, kind of hard to graph. I'd substitute in 1. So I'd have negative 1/4 times 2 to the first would be just 2. So it'd be negative 2/4, which is negative 1/2. So when we plug in 1, we get negative 1/2. When we plug in 2, we have negative 1/4 times 2 squared. Well, 2 squared is 4. Negative 1/4 times 4 is negative 1. So we've got the point 2, negative 1. So we could keep going on by plugging in points, or we could look for that pattern there. What are you multiplying by? It's harder to figure out when they're fractions, but don't forget the base of your exponent of x is always telling you what you're multiplying by. So we multiply by 2. Negative 1/2 times 2 is negative 1. So then negative 1 times 2 is negative 2. So when we're at 3, we'd be at negative 2. If I want to go further, negative 2 times 2 is negative 4. So we've got the point 4, negative 4. After negative 4 times 2, I'd be at negative 8. After negative 8 times 2, I'd be at negative 16. So you can see here, the right side is going down like crazy, right? It goes down by 1, then 2, then 4, then 8, then 16. So that amount keeps getting bigger, which means heading the other way, it's approaching 0, but it's never going to get there. So then on number 4, we have negative 4 times 1/2 to the power of x. So I've got my table. I'm going to get this one out of the way a little bit. So when I plug in 0, I know that 1/2 to the power of 0 is 1. So negative 4 times 1 is negative 4. So 0 in, negative 4 out. I'm going to plug in 1. So if I do negative 4 times 1/2 to the first, well, that's going to give me negative 2, right? Half of negative 4 is negative 2, so I've got the point 1, negative 2. I can plug in 2, so I have negative 4 times 1/2 squared. Again, 1/2 squared would be 1/4. A fourth of negative 4 is negative 1. So I've got 2, negative 1. Again, I can keep following that pattern. What do I keep multiplying by? Well, it's going to be a half. Negative 4 times a half is negative 2. Times a half is negative 1. I can also look here in the equation and see I keep multiplying by a half. So after negative 1 times a half, I'd be at a negative a half. And then times a half is negative 1/4, then negative 1/8, then negative 1/16. So I can see it's the right side this time that is approaching 0, but it's never going to get there. I could go backward, right? The opposite of multiplying by a half would be dividing by a half. So negative 4 divided by a half is negative 8. So if I go to negative 1, I'm at negative 8. Negative 8 divided by a half is negative 16. So that's where I'd be at negative 2. And I can see it's the left-hand side this time that's going down like crazy forever. So exponential graphs, one side either goes up or down like crazy. The other side is going to be approaching 0 like crazy when we're in the form y equals a times b to the power of x.